So welcome everyone. In this video lecture we will study about the material and energy balance. So this is the lecture 7 and 8 from the course Dairy and Food Engineering of 5th semester of the degree program BTech Agricultural Engineering. So starting with the introduction. So material quantities as they pass through food processing operation can be described by material balances. Means whatever the material goes into the system or any unit operation on which we have to apply the material balance. Such balances are made on the basis of or are the statements on the conservation of mass. Similarly, energy quantities that enters into the system can be described by energy balances, which are statements on the conservation of energy. Suppose if you consider that there is no accumulation into the system, means what goes into a process must come out. This is true for batch operation only, and it is equally true for continuous operation over any chosen time interval. So now, importance of material and energy balance. Why we have to apply material balance in any processing operation in a particular food industry. So material and energy balances are very important in the food industry. So these material balances are fundamental to the control of processing, particularly in the control of yields of the product. So we apply material balance in a particular food industry in order to control the processing. Okay, so the first material balances are determined in the exploratory stages. So we cannot directly apply material balance to the system. So there is a stepwise process. First, the material balances are determined in exploratory stages, that is in a laboratory. If suppose we have to we have to execute a particular process, for example say drying. So in order to apply more material balance over this drying process, we have to determine the material balances in the exploratory stages. So then these exploratory stages improve during pilot plant experiments when the process is being planned and tested, and finally checked out when the plant is commissioned, and then refined and maintained as a control instrument as the production continues. So in this way we have to apply the material balance. We cannot directly apply on the system, but when any changes occur in the process, the material balances need to be determined again. So this is the most important sentence, because if there is a change in the value of the material entering into the system, that will affect the material balance. So we have to it needs to be determined again. So the increasing cost of energy has caused the food industry to examine means of reducing energy consumption in processing. So nowadays the cost of energy is increasing day by day. So in this scenario, the energy balance plays an important role in order to control the use of energy in a particular food processing operation. Energy balances are used in the examination of the various stages of a process or the whole process, and even extending over the total food production system from the farm to the consumer's plate. Now, basic principle of material and energy balance. So this diagram shows the basic principle. So at the left side hand of this particular diagram, there are two boxes, that is raw material and energy in. At the center part there is a box which shows the process. That is, that process is nothing but the unit operation, that may be cleaning, grading, sorting, evaporation, drying, pasteurization, sterilization, whatever it may be. So, and at the extreme right hand side there are various products which are coming out of the system, that is product, main product, waste product. Also energy come out of the system in various form, that is energy in products, energy in waste, energy losses to surroundings. Oh, suppose mass entering system is indicated by MR1, MR2, MR3, means mass of raw material 1, mass of raw material 2, and M3. MR3 nothing but the mass of raw material 3. Then energy enters into the system in various forms like heat energy, work energy, chemical energy, electrical energy, which is indicated by ER1, ER2 and ER3, that is energy in raw material 1, energy in raw material 2 and energy in raw material 3. So unit operation, when all this raw material and energy enters into the system, some part of this raw materials and some part of the energy is stored into the system, and that is indicated by stored materials MS1, MS2, MS3, that is uh, mass stored, mass of the first substance stored into the system, and likewise. And also it is the stored energy is indicated by ES1, ES2 and ES3. Then product coming out of the system is denoted by MP1, MP2, MP3, that is mass of product 1, mass of product 2 and mass of product 3. So waste product is denoted by MW1, MW2 and MW3. Also energy in product is denoted by EP1, EP2, EP3, that is energy in product 1, energy in product 2 and energy in product 3. Also energy in waste is denoted by EW1, EW2 and EW3. Also some part of the energy lost into the surrounding, which is denoted by EL1, EL2 and EL3. Moving to the next slide. So then according to the law of conservation of mass, which leads to the what is called as a mass or material balance. So according to this law, mass in is equal to mass out plus mass stored. So this is the overall mass balance equation. Okay, if we see the previous slide, then in which we have applied the material balance. Okay, so that overall material balance is shown or indicated by this equation, that is mass in is equal to mass out plus mass stored. So raw materials, that is mass entering into the system, is nothing but the raw material, which is equal to product plus waste plus stored material. Okay, so that is mathematically expressed as summation MR is equal to summation of MP plus summation of MW plus summation of MS. So we know that summation of MR is nothing but the mass of raw material 1 plus mass of raw material 2 plus mass of raw material 3, that is total raw materials. Similarly, summation of MP is nothing but the total product, summation MW is nothing but the total waste product, and summation MS is nothing but the total stored materials. Suppose if there is no chemical changes occurring in the plant, the law of conservation of mass will apply also to each component. That is called as component mass balance. So that if for component A, Ma in the entering materials is equal to Ma in the exit materials plus Ma in stored product, or Ma stored in the product or plant. For example, this component balance can also be shown by this example of a sugar plant. In a plant that is producing sugar, if the total quantity of sugar going into the plant is not equal by the total of the purified sugar and the sugar in the waste liquor, it means there is something wrong. Sugar is either being burned, that is chemically changed, or accumulating in the plant, or else it is going unnoticed down the drain somewhere. In this case, the material balance equation can be written as Ma into R. MAR is equal to MAP plus MAW plus MAS plus MAU, where Ma is nothing but the mass fraction of component A in raw material. MAP is nothing but the mass fraction of component A in product, plus MAW is nothing but the mass fraction of component A in waste product, and MAS is nothing but the mass of component A stored into the system, and MAU is nothing but the losses and needs to be identified. So raw materials, therefore the overall mass balance equation can be written as, in this case, raw material is equal to products plus waste products plus stored products plus losses, where losses are the unidentified materials. In the same way, we can apply the energy balance to the system. System means any unit operation that is under consideration. So just as mass is conserved, so is energy conserved in food processing operations. So the energy coming into a unit operation can be balanced with the energy coming out and the energy stored. That is nothing but energy in is equal to energy out plus energy stored, which is shown by the equation summation ER is equal to summation EP plus summation EW plus summation EL plus summation ES, where summation ER is nothing but the total energy entering along with the raw materials. Summation EP is nothing but the total energy leaving with the products. Summation EW is nothing but the total energy leaving with waste materials. Summation EL is total energy lost to surrounding, and summation ES is nothing but the total energy stored into the system. So these energy balances are often complicated as compared to the material balances, because forms of energy can be interconverted. For example, mechanical energy to heat energy, that is, this is the conversion of heat energy from mechanical to the heat, but overall the quantities must be balanced. So this is the important part, as when we apply material balance to the system or energy balance to the system, that material on energy balance must be applied through some steps. We have to go stepwise to find out the material balance in the particular unit operation, or to apply the material balance or energy balance in a particular unit operations. The first step is in making a material balance is to define a system to which the material balance is to be applied. First, we have to define a system to which we have to apply the material balance, and then we have to draw a schematic, and boundaries should be fixed from which inlet and outlet streams can be defined. So just we have to draw the box and in that box we have to write down the name of that unit operation or that particular process. And from left hand side we have to show the arrow. That arrow will show that that material is entering into the system, and at the right hand side arrow will indicate that material is going out of the system in the form of product. So in this way we have to define a system. Then we have to draw schematic of the system, and boundaries are set from which inlet and outlet streams can be identified or defined. Write down the next step. Our second step is to write down the available quantitative information. Whatever the information is given in that particular numerical or in that particular process, that all the quantitative information we have to write down in that uh, schematic drawn into the first step. The quantitative information may include the flow rate of incoming and outgoing streams and their compositions. The third step is to select a suitable basis for calculations. In some numeric or in some material balance or energy balances, there is no given some suitable basis. That suitable basis we have to assume in that case. In some examples or numerical, that suitable basis is given, so in that case there is no problem to apply the material balance. But if it is not given, we have to consider that every addition or subtraction must be made with the same basis. The fourth step is write the overall mass balance equations and component mass balance equations of entire process and around each piece of equipment or unit operation. Then we have to form an algebraic equation or number of algebraic equations, and these algebraic equations are solved for unknowns. In order to provide unique answers, there is a one trick that the number of equations must be at least the same as the number of variables present in the system being under consideration. So select an appropriate set of balance to solve these equations, and then we have to check the answer by submitting into the material balance equations. Are the answers reasonable? If the answers are reasonable, means left hand is equal to right hand side, that is mass in is equal to mass out, or energy in is equal to energy out. In that condition we can say that whatever the material or energy balance we applied on the system is true or correct. If not, then the material balances needs to be determined again. Then if the left hand side of that equation does not match with the right hand side, in that case it is said that the material balance is not applied correctly to the system, and in that case we have to determine it again. Thank you. So in this way, in the first pass we studied about the importance of material and energy balances, the basic principle of material and energy balances, and the steps followed while applying material balance to the particular system or particular unit operations. Thank you.